I'll start with the session. So a little bit introduction before I start. Yeah. So a little bit introduction before I start is that I hope you guys know about the blockchain technology and the Ethereum technology in general. Today I'll be teaching. I'll be discussing or like showing you guys how we can create a simple decentralized application on based upon the Ethereum blockchain network, and we'll be using the Node.js Express alongside the EJS template engine. And for the blockchain part, we'll be using some Go Ethereum client, Truffle, and Web3.js for communication. We'll get into them in detail as we do this thing. So as for the project that we will be building today, I thought about it, how to bring up a simple application. So I went with an application that will help you issue certificate on top of blockchain. So I mean that's actually not that much of a complex application, or the blockchain part doesn't need that much of an understanding. So anyway, if you guys want to understand a blockchain, you guys can like go to our KBA site, which has a free auditing course on blockchain fundamentals. So if you guys are interested, you guys can look into that. Now let's start with our application building. So imagine Kerala Blockchain Academy has just started up, and we want to put our certificate on top of blockchain. I mean, whenever we issue a certificate, we want to be secured. We want that certification to be secured by the nature of blockchain. So how we go about building that? So obviously that will fall into the category of the team Ethereum on Kerala Blockchain Academy, and from there they have to like build an interface, plan on how we can store the data on the blockchain, what are the data that we going to be stored on the blockchain. Those kind of things will be planned out. Prototype will be made. So I'll just guide you guys through a simple application that will follow these steps. So yeah, the first step is to understand what are the things that we need to store within the blockchain. So I think as far as the certificate is concerned, the certificate should have an ID, a certificate ID, to uniquely identify that. It should state to whom that certificate is awarded, and for which course that certificate is awarded for, and the issue date. Yeah, that award will cover the details regarding a certificate. I mean, when developing a decentralized application or when developing any kind of application, you don't really need to put everything into the blockchain. Like, we can do that. It's not like we can't do that, but we just need to put the things that need to be immutable, or that things need the protection or the nature of blockchain. And after that, we can like use a combination of other database also. So in our session, we'll be concentrating mainly on the blockchain part. I have already like called up the interface for the for application that I will give you guys, so you guys can like follow me up if you want, and everything like that. So let me just quickly introduce you to my environment. So the development environment that I'll be going to use for this. So I'll just turn off my camera in case I might having some issues of internet over here. So if you are not able to hear me during the presentation, please let me know via chat, or just unmute your mic and tell it me. Okay, so as you can see, I am using Linux Ubuntu system. So basically it is the latest version 20 LTS. So I'll be showing all the demonstration, all the application in this particular operating system. And this is actually followable, both followable in Mac OS or Windows. If you have all those operating systems also, there will be small changes, and I'll mention those whenever possible. I mean, the programming, all those things won't be any different, there will be little changes when running the Ethereum client. Other than that, there won't be any differences. So as I mentioned before, we'll be using Node.js for the server-side coding, and also for developing our front end also. So yeah, I'm using this version of Node. It is 14.x. So this program is actually has no compatibility issues with 10, or I won't go till 8, but 10 and 12 is also okay. Then this is the Node package manager version. So in any case, I mean, we'll be focusing on blockchain, but if you guys have any trouble understanding any of the technological stack, or any of the things that I described in this session, you guys can directly go ahead and ask about that. I'll try to explain it as much as possible within the time limit. So do not hesitate to ask anything. With that said, let's go to the first step. The first step for us is to develop a smart contract. So a smart contract is actually simply saying, if you guys have worked with the block databases, blockchain is something like that, but it has an entirely different structure. So if you want to store something and you retrieve that on the blockchain, or if you want to have something written to the blockchain, we usually use that with the help of smart contracts. So basically, I think you guys will be familiar with the Bitcoin. So after Bitcoin was released, someone known as Vitalik Buterin, that was a part of the community that was formed around the Bitcoin community, wanted to create a blockchain that will be general for any use case that is going to come up in the near future, or in any future. So he wanted to have a scripting language on top of the existing blockchain community, but the Bitcoin blockchain community was not ready for such change. They only wanted that blockchain for financial transactions. So that was not really up to mark for Vitalik. So he himself, alongside some other people, the notable persons were Gavin Wood, created a blockchain where people can code their logic in. So one blockchain, one big blockchain, and anyone can code in their application on top of that. So that is how the Ethereum blockchain came into existence. And the language, or the scripting language, or the business logic is being coded in many different languages. We have one called Solidity, which is actually based on or influenced by C, Python, and a lot more of JavaScript actually. Most of its syntax are based on JavaScript. So if you look at Solidity, you might think that this is a smaller version or a stripped down version of the JavaScript language. So for developing a Solidity program, the best and the easiest way is to use Remix, which is actually an online IDE. If you just go to Google and type Remix IDE, I already loaded it up, but anyway, so usually it will be the first link, so remix.ethereum.org. You just need to go to this location. And you can see this is the page or the home screen for the Remix IDE. We have a lot of features available over here, but for this particular session, we'll go through the code editor, compilation, deployment, all those things. So moving forward, if you we'll just look around a little bit. On the left side, you can see a file explorer. The file explorer is where you can, just like any other code editor or IDE, like Visual Studio Code, we can use that to browse through the existing contracts or any contract that we are coding in over here. And it's a simple file explorer. Just the one thing you need to keep in mind is that you can create many files over here, but all these files will be stored within the browser cache. So basically, if you clear the cache or uninstall your browser, then all the files that you have created will be lost forever. Like, you can save it as a gist in the GitHub, a code snippet as in the GitHub. But other than that, if you want to save any file, you have to press Ctrl+A, Ctrl+C, and copy it to a local file. So just keep that in mind because there are many people that lost code by like keeping them over here. So anything that is over here will be lost after, like, for example, if I have so many files over here. So if I create a new incognito tab and I go to remix.ethereum, I think that will take some time. Anyway, that I let it load. So the program that we want to create, or the Solidity or the scripting logic that we want to create, should be able to store the details regarding a certificate. And the details that we want to store are the name of the course, the name of the person that it is going to be awarded to, maybe a little bit grade, I mean like a division of mark or something like that. Then the issue date. I think that will cover a normal assembly certificate, and then we can create an interface for that and write data or read data from that. So this will be the data that
Hello,
we need
sir.
to store within the cloud. Yes, tell me.
Sir, are you screen sharing? It's
Yeah, I'm
not visible.
sharing the screen. Oh, it's not visible. Sorry about that. So I think at some point it got, yeah. Thank you for that. Okay, so it's still visible, right?
Yes, sir. Now it's present.
Okay, so I think
Thank you, sir.
I'll just go around through it. Yeah, so if you guys just go to remix ID, you can just simply see this location. I think I have fresh one over here. Yeah, so this will be the remix ID homepage. There are a lot of features over here, advanced and normal features, but basically it's a place where you can code and compile your smart contract, and then move on and run that smart contract also. So if you see on the left side, you can see as File Explorer. Just to be clear, these files are provided by the Remix ID developers themselves. Like they have provided you with some smart sample contracts. The first one is to store and retrieve a numerical value. This is for privilege escalation. Like if you want to set privileges for a particular smart contract, this can be used. Then if you have a voting system, if you want to have a voting system, this particular one is for voting on proposals that is going to be proposed on a company. Like if you have a board of people, then those people can vote on a particular piece of proposal. And yeah, this contract is for that. And if you want to deploy contract manually by using Remix ID's code, then you can use these. These are for those things. And then a testing file for the voting contract, and finally a README file. So that are the things available by default in the Remix ID. It's not it's not the only way to code, but this is actually a very good way. If you want to run Remix ID on your local computer, that is also possible. You can either run that using, I think you can either run that using the Docker. Yeah, sorry, it's the wrong place. So yeah, like you can just simply clone this repository and run it in a normal way, or either you can like use the Docker and you can just simply run it using this two commands actually. So I'll just put that link also in the chat if you guys are interested to do in doing that. It's not. You just need to simply follow the instructions given here. You won't come into any problems with that. So yeah. Now let's go ahead and create a contract for ourselves. So the contract will be able to store the details regarding the smart contract, and it should be able to allow us to retrieve that details too. So yeah, let's start. To create a new file in Remix, you can click on this icon over here. and you can give it a name. I'll just call it certi. Yeah, so already had a file, that's why it's showing like that. So basically every Solidity file will have an extension called .sol. So whenever you are creating a file, you can either provide that extension or you can omit it like I did before. And after that, you can like start coding your application, your smart contract. So the first, let's just, yeah.
So there is a question in the chat. Are PPA packages available
Okay, I
for
didn't.
remix?
Yeah, PPA no, PPA package is not available for remix. You can only compile it from the source code or use the Docker to do the same. Okay, so give me 1 minute. Okay. So the first line for beginning any Solidity contract is to specify the license upon which we will be building this code. So you can use this command. This is actually a comment. It's okay even if you don't provide it. It will only show you with a sample warning, but it's also okay. I mean, it's on top of every other code that is provided over here. So I'll just copy first one there. Then the second line, you can specify the version of Solidity you will be using. I mean, there are different versions of Solidity ranging from 0 to 0.8, like 0.1 to 0.8. So you can specify which version of Solidity you will be using. So for we will just use the latest stable one. Like people might prefer using 0.7.1 because 0.8.8 8 series was just released recently. So like it's almost 1 or 2 month old. So some people prefer using the previous version for like security, or if there have been any errors concerning this version. But for this exercise, we can use the 8.1 or 8.0. Then followed by, you can specify your contract. So like I said, this is inspired from CCPP programs or CPP programs. So some object-oriented concept has been passed down to Solidity program. So just like we declare any other class, we can specify a contract using the keyword contract, followed by the name of the contract, then open curly braces and close it. As you can see, the remix ID provides simple syntax highlighting and a little bit of IntelliSense and a little bit formatting also. If you like press Control \, then you can have a comment those lines of code. Like you can do it like this and press it again to uncomment. There are a little bit of like help from the remix ID's code editor, but it's not a fully fledged code editor. So just keep it like that, or treat it like that. So let's start with a variable or some kind of data structure to store the details regarding the certificate. So just like most of the language, Solidity also supports something called struct. So struct is actually a user-defined variable or user-defined data type that can be used to combine other data types to form our own data types. So I will be using a struct. You can use the keyword struct to create a struct. So I'll just call certificate and open a curly braces. If you press enter, the Solidity will automatically close the curly braces. Not the Solidity, the remix ID. So I was thinking of going with a simple data types like string, I mean, it's easy for us. String is actually a dynamic data type. Basically, what you say by dynamic is that you can't really set how much limit, like you can say string 5, like only 5 characters or 5 letter string can be stored inside, like that. You any kind of input provided, these space will be decided upon runtime. So that's why we call dynamic. And Solidity is a statically typed language, so you have to specify the data type for the variable. So I'll start with string course name. So you have to specify the name of the course. Then candidate name. Then we can specify grade. So I'll be going with grades like okay, I think Solidity got a little struck over here. Yeah. So I'll be going with SA. So those kind of grades. So that's why I'm providing it as string. Then like the date of issue, that can also be stored as a string variable. String is not the only variable or a data type available within Solidity. There is a uint and int for storing numerical values, like uint, and int is also available there. There is Boolean data type, bool for storing true or false. Bytes, there are so many data types available, but for us, our use case, we'll use the string. So we have a new variable called, or a data type called certificate, and any variable created using the certificate will have these members: course name, candidate, grade, and date. So next, I want to store multiple certificates, right? I mean, I want to store multiple certificate based on any primary key. So I want to have a primary key, and using that primary key, then I can like store data and retrieve that data using that, right? So we discussed about having a certificate number. So I'll be using that certificate number as a way in which we can store and retrieve the data. Inside the Solidity, they also provide a reference type data type called mapping. So mapping is actually a key value pair. So for a particular key, there will be a corresponding value, just like the hash table. For each corresponding key, there will be a corresponding value. So I'll be using that mapping, and I'll be for every particular string, there will be a certificate variable. So I'll be creating a mapping between a string to the struct. So let's try to create that. So you have to specify the data type. You can use the mapping keyword, open the parentheses. Then you have to specify the data of the key value, or the data type of the key. Then specify the data type of the value. So here it will be certificate, our newly created data type. And you have to specify a name for that particular mapping. So I'll say certificate details. Yeah. So in Solidity, you can specify the, I mean, there are a lot of different kinds of modifiers. So you can specify who can access a particular variable or a particular function within a smart contract. So there are different kind of accessibilities. So one is called public, then we have private and internal. So a public variable can be accessed by the contract itself, any external user like us, or any other contracts, or any child contract of this particular contract. Then for internal, that means only the child contract and the contract itself will be able to access that. And in terms of public means everyone will be able to access that. But when declaring a variable, and one more thing is that these variables, or all these variables that is declared inside the contract body, are called state variables. These are called state variables because these will affect any changes that is happening onto this variable will affect the entire state of the blockchain. The blockchain is actually a state machine. If you simply compare it to a door, A door will have at most 3 or 3.5 states, like open, half open, closed states. So just like that, for us, we'll be having a state. Like for my state, currently my state will be like I am teaching you guys, and I have a computer open in my front of me, and I am coding this code. So that will be my state. So Ethereum is also a collection of states, and Ethereum uses something called addresses. So to interact with any Ethereum network, you should have an address. Basically, an address is just like an account you will have on Facebook or any other normal sites. Basically, here you will have something called a private key, just like a password. Using that private key, you can access your addresses or accounts on Ethereum, and this will be majorly controlled by an user. So yeah, the reason, that's all about the addresses. The reason I am setting this state variable as public over here is because during the compile time, the Solidity Compiler will automatically create a getter function for this specific variable. So the function name will be the variable name, but we don't really need to write another function to retrieve the data that is contained inside this particular variable. So we don't really need to write an extra function for that. We only need to write a function to insert data into this particular data type. So for that, we can use a function, which is just like every other programming languages. So let's create a function called new certificate. And followed by, you need to open the parentheses and specify the inputs that you want to provide. So what are the inputs that we need to store? We need to have this course name, candidate name, grade, date of issue, and also the certificate number. Like we have a key type and a value type. So we already filled in the value types. We need the course name, candidate name, grade, date, and alongside we need a primary key or like a unique key for uniquely identifying each certificate. So that will be of the type string, and we can call that certificate ID or something like that. So as mentioned earlier, string is a dynamic type. So in that case, you have to tag this string variable with a keyword called a memory. The memory is used to indicate any function parameter that is a dynamic variable. Like if you are using arrays, you have to tag it as memory. If you are using any other dynamic type variable, then you have to tag it using the memory keyword. So yeah. So the first one is certificate ID. Then we have course name. I'm just putting underscore in front so that we can recognize from the function parameters and the actual state variables. Yeah, I forgot the candidate name. Okay. Semicolon over here. Then followed by, I have to specify the visibility of the function. Just like state variable, functions also has visibility or accessibility modifiers, and it's the same as the state variable, but it has an extra one called external. And if you tag a function as external, then the child contract will not be able to access that. That's the only difference. Then followed by, I'll just open the curly braces, close them, and now I need to add these. Now I need to store it to this particular mapping. So to do that, you can specify the name of the mapping, then specify the key inside square bracket. So the key is a string, right? So we are using the certificate ID as the particular key, then specify that equal to, you need to create an instance of that particular data type, certificate. and you need to store it as a certificate data type. So you can like just like creating a class, you can like create this address you have specified in the certificate struct. So otherwise it will mismatch. Here there won't be any problem, but in case if you have different kind of data types, then that will be a problem. Here the only problem will be that if you miss between like miss the order between candidate and course name, then the course name will have the candidate name. That's the only problem here, because everything else will have the same. We have grade and date. So yeah, that's hi guys. So I think I lost network connectivity in between. Can you guys, any one of you tell me how far you guys heard?
Sir, till the end was there. Only the last few, just now it just got cut. Yeah.
I mean, do you? I mean, let me just share the screen. So you guys. Yeah, sorry about that. I think I have some kind of. Okay, thank you, Shravan. So I think I'm presenting my screen, right? You guys can see my screen.
Yes, sir, we can see.
Okay, thank you. Okay, so after the course name, I provided the candidate name, grade, and data. Sorry, date. So this is how if you want to insert a data into a struct doing. This is one of the way. So if you guys need to know other ways, I can like provide reference to that. So this is our contract, but I think we can add a little bit more details into this. So like we can constrain from this is a certificate issuing contract, right? So only eligible people we should be able to access this particular, able to add new certificate into this particular contract. So how can we do that? So we should be able to constrain a particular account or a particular address. In our case, the Ethereum has addresses, right? So we need to constrain a particular address. Only a particular address will be able to add certificate into this particular contract. So how can we do that? So we can do that by checking who calls this function. Whenever a function is called, you have to pay a particular amount of cost. So you have to specify the function. Why we need to pay the cost is that basically the Ethereum is, their concept is something called the Ethereum world computer. So the concept of Ethereum world computer is that for the entire world, we have one single computer. So that will be formed as a group of different small computers, but for an entire world, we have one big machine. And to maintain the integrity of such a machine, we need to follow, or we need to assure three natures or three properties of that machine. And we can call those three properties as determinism, isolation, and terminability. So the deterministic property means that any program that is going to be run on the blockchain, like any smart contract that is going to be run on the blockchain, any operation should be deterministic. For example, you have an equation A plus B, and at any instance or at any time, you give two numbers like 2 plus 2. You can provide values for A and B as 2 and 2, and it should return 4 at any moment it is called. So for any operations, it should be deterministic. The next nature is isolation. Any smart contract should be isolated from any other program that is running on that particular computer, and any other program that is running on that particular computer should be isolated from this smart contract. That is, they should not be able to interact with each other. There should be a particular ways in which we want to interact with this blockchain network, but other than that, there should not be any unknown factors that interact with this. It should be a controlled isolation. Next, there is something called terminability. Any operation or any smart contract operation that is going to happen, not only smart contract operations, any operation that is going to happen on this blockchain network should be terminatable. Like any operation, for example, we are going to run a loop, but we want to stop that at a particular instance, or we want to stop it at, it should not go on an infinite loop. So if we want to stop that, then we should be able to stop that at any particular moment. So these are the three natures. So to enforce the second nature, the isolation, the Ethereum community created a virtual machine. These Ethereum clients are called Ethereum virtual machines. So these are implemented in many languages called Go Ethereum, Python, CPP, etc. That's creating a virtual machine that solved the problem for isolation. Determinism was solved using algorithms, different kind of algorithms. And the last step, determination, was solved using introducing a fee meter. So for every operation, like there could be an in terms of assembly language, add operation, push operation, pop operation. For that, each operation we specified a value. And all these operations combined, if the value exceeds a particular limit, then we will stop the execution of that particular program. That's the fee meter. And for Ethereum, we call that fee meter, or we call that fee a transaction cost, and it is always paid in something called Ether. And internally, this Ether is always considered in its smallest denomination. Like for example, Rupee has paisa, like 50 paisa, 10 paisa, those like that. So just like that, Ethereum also has smallest denomination, and for the smallest denomination, we call it Wei. So it is like 1 Ethereum followed by 18 zeros. So it's into 18 zeros. So that's how that works. And this for each gas cost or this payment, like for any operation, for any write operation that is going to be happening on the Ethereum network, we have to pay a gas cost. We call it gas cost. We pay that in Ether, and that has to be paid from a particular account. So if you are interested to do any particular write operation in the Ethereum, you should need an account, and based on that account, we can limit a certain account to only a certain account to access this function. So how can we do that? So the first thing is to record the function. I mean, I will just take a particular address. Whoever deploys or whoever stores this contract to the smart blockchain network, I will take that particular address as the administrator account for this particular smart contract. So to do that, we can use something called constructor. So just like any other object-oriented language, a constructor will be invoked whenever we store or whenever we deploy this smart contract. The operation of storing the smart contract into the blockchain is called a deployment. So whenever we store this smart contract, we compile this smart contract into some things, and when we convert that into a transaction, then using that transaction, we store that into the blockchain. So at that time, this constructor will be triggered, and we can write any message inside that. Then inside Solidity, we have another unique data type called address, which is used to store the address of an externally owned account. I mean, these accounts that are owned by us are called externally owned account. There is another kind of account called contract address that will be available for a contract when it is deployed. We will be going to see that when we deploy this contract. So I'll call this variable admin. And whenever someone deploys this, or whenever someone calls a contract, or whenever someone calls a transaction, that address will be stored inside a global value or global variable called a message.sender. Oh yeah, so you need to open and close the parenthesis for constructor. Like you can provide input for the constructor also, that's why there is a parenthesis. So now we have value as the administrator for this particular contract, right? So we can enforce something called a modifier. So we can use something called a modifier to check a condition before we execute a particular function. So let me just create a modifier called only admin. So we can use the keyword called modifier, and only admin is the name of the modifier. Open and close the braces. Then you can use require keyword to check a Boolean operation. For example, whoever is sending a particular transaction will be stored inside the message or sender, and whenever the function is called, I mean, the only admin will be triggered when the function is called. We'll be appending that to the corresponding function. But the condition is that whenever a transaction is called, it is checking if the stored data inside the admin matches with the address of the caller or whoever is calling this particular function. If not, we can provide a message like not enough privilege or something like that. Then we can specify when to execute the function body. We can specify that using this. Oh yeah, that's not a semicolon. So we can specify that using an underscore semicolon. And how we use this modifier is that we add that to the function header. So whenever this function is called, first this statement will be executed, then followed by that the function body will be executed. So this thing indicates where the function body should be executed. For example, if I put it over here, it will first execute the function body, then execute that require condition. Now, another matter with the require condition is that if this condition is not satisfied, the entire transaction will be reverted. Any changes that happen to the blockchain state will be also be reverted. So that marks the end of our smart contract. So if you guys have any doubts regarding the smart contract that we cooked up right now, you guys can go ahead and ask. Or you guys can put the doubts in the chat also. Yeah, I mean, it's not JavaScript. It's actually a stripped down version of JavaScript, and it's called Solidity. Oh, if you meant the whole experiment or the whole session, yes, we will be using JavaScript. And if any of guys are interested in Python or Python-based coding or something like that, at the end of the session, just ask me and I will point you in the right direction for that also. Okay, I mean, I mentioned Python because that is the next best thing after JavaScript for development in Ethereum. There are other languages too, but you have a lot of community support and up-to-date updation for the Python versions also. That's why I mentioned about that. Okay, so moving on, the next thing, now that we have our code, right, we need to compile this thing and execute this thing. So to do that, we have something called Solidity Compiler that can be available over here on the left side. If you look at here, we have something called Solidity Compiler. So I have used this previously. So my Autocompile option was on. That's why everything that we compiled right now got automatically compiled and there was no error. In case if that there was an error, it will be shown on the left side over here and also in the editor itself. So if there are no error, a tick mark will be shown. Let's go ahead and explore different options available in the Solidity Compiler. So the first thing is that we can specify which version. So yeah, these are the versions available. I think for the local installation, the versions are available up to 7.4, and 8.1 is actually the latest introduced Solidity version. In case if you guys want to follow the cutting edge development or the up-to-date development of the Solidity, then you can like use this option called include nightly builds. So at that time, you'll be able to nightly build means it's like kind of like an alpha or prototype builds. It will release on a nightly basis or like 2 or 3 nightly basis. So you guys can currently they are like developing on 8.2 version. So you guys, if you want to work with that, that can be also be used. And this one 8.1 commit, this will be the stable release for that particular subversion. But for us, we will be using the 8.1. I think we provided 8.1. Yeah, we will be using 8.1. Then there is another language called Yule. That doesn't have that much of a community support. We'll go with Solidity. And the Ethereum client, like as you know, it started almost around 5 to 6 years before. So it has different versions. So it has different evaluation versions. Like if you want to build your smart contract for any particular version of that Ethereum client, then you can choose that particular version. I mean, each version has its own name, but we'll go with the latest version, that is the compiler default. Then we have some options called Autocompile, which actually recognize any changes that is happened into the editor and compile it automatically. Enable optimization. It will optimize the gas cost whenever you are going to deploy the contract. I mean, after that, there won't be any optimization, but there will be an optimization for the deployment cost of that particular smart contract. Hide warnings. If you have any warnings, I mean, we don't really have any warning, I think. If I specify public over here, that will get us a warning. So if you want to hide those kind of warning, that's possible. So yeah. It's basically in the new latest versions of Solidity, you don't need to specify the visibility for the constructor. That's why it was a warning instead of an error. In case if you haven't specified the license version, then you will also get a warning, but it's not an error. So you can specify anything like GPL is general public license, like GNU general public license. You can specify MIT or whichever one you are working on, like whichever one your code is compatible with, or if you are your own, then you can specify that. So after writing the code and selecting the necessary options, you can go ahead and compile your contract. So make sure the name of the file, like if you look over here, this is the name of the file. The name of the file is listed over here. Like if you have selected anyone else, then that file will be the one being compiled. So make sure you have selected your own version. And if the compilation is successful, as I told you earlier, there will be a tick mark over here. And other than that, you can see different options over here. So any contract, compile the contract. Like for example, if your contract file have multiple contracts, like I also have another contract called A over here, then that also will be listed over here. This will be the list of all the compiled contracts over here. Then we have something called publish on SOM and publish on IPFS. So along with these decentralized blockchain systems, we have some decentralized storage systems also. So the one is called SOM and another one is called IPFS. As SOM and IPFS is both have a good community and they are developing it. But if, in my opinion, IPFS has a better community and has a better client. If you want to run a SOM node, I mean, these are decentralized distributed storage, so you have to run your own nodes. So if you want to run a SOM node, you have to run a Ethereum node also, because the SOM protocol is actually built on top of the Ethereum protocol. So if you want to run a SOM node, you have to run an Ethereum node also. That's actually a very resource intensive process. But if you want to run an IPFS node, you just need to run a simple IPFS client. And yeah. So what are the use over here is that you can simply store your code into the IPFS or SOM network and share that to your colleague. So I prefer the IPFS, so I'll show you a demo how I can share this code with you guys. So I simply say publish on IPFS. And I'll get a URL. So there are two URLs. So one is for the code and another one is for metadata. We'll come into metadata, but first I'll share this code with you guys. So as you can see, this is actually a partial URL. To get the full URL, you have to type ipfs.io followed by the URL that I just copied. Then press enter, and you can see that it is available on this particular location. IPFS is actually a content-based file storage system. So if you insert a content or a file into the IPFS system, they will hash that particular file, then provide you with the this particular file's hash. Then that hash will be used to uniquely identify each file. That will also help us to reduce duplication, because if you are going to write the same file into the IPFS, then they will just retain the hash instead of creating a new location for that. So if you guys go to this location, you guys will be able to access the contract that I just coded up. Now, now that we both have our contract and we have compiled it, you guys can go ahead and compile that. I mean, if you want to. After that, we have deploy and run transaction. All these facilities inside the Remix IDEs are considered as plugins. So if you want, you can like turn them off. Now, just like the compiler, you have different options for the deploy and run transaction. So just like I mentioned earlier, the process of storing smart contract into blockchain is called deploying. So let's go ahead and store or deploy something into the blockchain environment. So over here you have different options. The first option is called environment. The environment means to whichever blockchain you have connected yourself. So basically you can connect to JavaScript VM, which is actually a simulation. It's not an actual blockchain node, which is actually a simulation via which you can deploy, play around with your code. Then you have injected Web3. If you want to connect to wallets like MetaMask, then you can use this option. Then Web3 provider, you have an actual Ethereum node running on your system or on any other computer, then you can connect using this option. So yeah. Then the next is accounts. So if you it will over here it will list any open accounts, like you have to unlock accounts using your private key or using your password. That will be based on the wallet that you will be using for Go Ethereum. I mean, the client that we will be using is the implementation of EVM in the Go language. So for Go Ethereum, it will be a password because they have an inbuilt wallet with them. So for JVM, the simulation that we are going to use for testing purpose already have like around 10 accounts pre-funded with Ether, so that we can play around with our contract. Then the gas limit. I mentioned earlier, like we are using a fee meter to like enforce the property terminability, right? So the limit of this particular operation or any particular operation that we are going to use will be specified over here. So if the Ether price or the gas cost exceeds this particular limit, then that particular transaction will be reverted. And if you are thinking about what will happen up to the gas cost that used, what will happen to the gas cost that already used, that will be used and you won't get that back. But if there is any remaining gas cost, that will be refunded to you in case of an accidental revert. But in case of a gas limit revert, you will lose all the gas limit and the transaction won't happen. So before we deploy, let me help you understand how we deploy this, or how this smart contract is going to be stored onto the blockchain. So when you compile the smart contract, we use something called Solc, which is a JavaScript-based module for compiling the smart contract. So we use the Solc module to compile the smart contract. And when you compile this particular smart contract using the Solc compiler, we get a lot of outputs actually. So if you click on this compilation details in the Solidity Compiler tab, you can see a lot of outputs. Basically, we have metadata. I mean, those metadata are like listed out individually also here. We'll just look at the main ones. The first one is bytecode. So we all know that this is actually a high-level program. We convert that to a low-level language. Then only the machine can understand that. Then it can begin to execute that. So we compile that to bytecode, which is usually represented using hexadecimals like 0 to F, like 0 to 16. 0 to 15, sorry. So 15, this will be the whole. So we usually use that to represent this. And then we have something called ABA. Then we have, the assembly code. So before I mentioned that for free meter, for each particular operation, like the push operation, the car value operation, jump operation, add operation, for any particular operation, if you like consider them in assembly language, or for any operations that is going to be happening, it will have a particular value. For example, if you just search it, these are called opcodes. I mean, these assembly things are called opcodes. So if you want to know the gas cost for that particular opcode, then you can use this spreadsheet as the reference. So this is actually the spreadsheet someone has prepared based on the yellow paper of the Ethereum implementation. So as you can see over here, for each particular, not for the gas, but for each particular operation, you have a gas cost. So if you sum up all these operations, like there will be a lot of operations. If you sum up all of this, then you will get the gas cost for the deployment for that particular contract. And for each function, there will be separate opcodes. And if you sum up those, then you can get that too. So this is actually the details regarding A. That way, we don't really have a lot of assembly code because it's just an empty contract. If you check on one for our contract, you can see this is the entire operation that is going to happen when we deploy that. I mean, that's a lot of there. Yeah, let's just not look into that. So that's how we calculate the gas cost for a particular operation, that is a particular function that we are going to call, or whenever we are going to store the smart contract. The next important one is called AB. So as I told you before, the smart contract will be compiled into bytecode, and then that bytecode will be converted into a transaction. Then that transaction will store that particular bytecode into the blockchain. But we will be calling from a high-level language like JavaScript or something like that. So how we know how to call this thing, right? So for that, we need to have two things to know. The first one is we need to know which contract or where this contract is stored. And then we need to know how to call this particular contract. For example, how to call this particular function. To call this particular function, we need to know the name, the type of the function, the visibility of the function, the variables that are going to be as the input of the function, and if there is any output for that particular function. We need to learn that. So that can be obtained from this AB. So if I just copy paste the AB over here, you can see all the available, publicly available things that we can operate in this particular thing. So if you check, as I told you before, if you tag a state variable as public, an automatic getter function will be generated for that variable. So let's check if that happened. Certificate details. So we have a function, and with these many outputs. It's of the mutability. The state mutability means for each and every function, we have something called mutability. We have something default. The mutability handles, I mean, mutability signals, or it indicates how the function interacts with the state of the blockchain. So if the function reads and writes from the blockchain, and then it have the default immutability. If it only reads from the state, then it is called view. If it only if it does not do anything with the, like it doesn't interact, write or read from the blockchain, then it will have the mutability called pure. So if you have any particular calculation to be enforced and you don't want to store the output of that calculation into the blockchain, then you can use the pure functions. So basically, it's a JSON formatted string, like a key value pairs, and it will tell you how to call that particular function, like the inputs for that particular function, name of that function, output for that function, state mutability, and type. Okay, then. So I'll just delete that. So that are the important things. So the next thing, so we know how to call a function. So we need to know which contracts function we need to call. So whenever we store this contract into the blockchain or deploy this contract in the blockchain, so let's just go ahead and deploy our contract into this simulation. We will be in returns given. Oh, so sorry, I deployed the A. Let me just delete this one quickly. Yeah. So let me just go ahead and deploy our contract into this simulation. And yeah, so over here you can test out if your contract works or not. But if you look over here, you can get the address of that particular contract. So in Ethereum, we have two kind of account addresses. So the first one is externally owned account address, which will be controlled by us, or basically a private key, a password, and an account address for the contract, which will be controlled by the code associated with the contract. So using this contract address, like it will act as a pointer to which contract we want to call, and we can create a function call using the ABI to this low-level deployed bytecode. So that's how we interact with the Ethereum. So let's just check if our contract works or not. We can specify a certificate ID, a course name, candidate name, grade, then date. So 22. Everything is string, so everything is allowed, like special character numerals, everything is allowed in our input, so that's not a problem. Then transact. You can see the details regarding that particular transaction. The status. True means it has successfully completed. The transaction hash, which is used to uniquely identify a particular transaction. From which account, like it will be the first account that we select over here. As you can see, a little bit amount of gas cost was deducted from that. A little bit of amount of ether was deducted from that account as for creating a new entry in that smart contract. And to address, so it is a smart contract here, that's why it is shown as here. The gas limit, the JVM actually shows you an incorrect transaction counts cost. So if you just add them up, you can see that. Then hash of the code, then the decoder output. So this is actually hash of the input, and this is actually the input itself in hexadecimal form, and this is actually the decoder input. You can see the parameters and value over here. And if you want to retrieve, you can specify that key, like you used to certificate ID over here. So using that, we can retrieve that also. So that's the entirety of our smart contract development. Next, we will be moving on how we can create, how we can interact how we will be using a decentralized application. We will be concentrating mainly on the server-side aspect, like how the communication between the blockchain and how we can read and write data using the smart contract. The interface part is, I already coded it up. It will be available for you guys also. That I'll just provide you guys with the link. So you guys can like directly go ahead and clone it, and you'll be able to get a template for this particular project. So I'll just explain this template. So after you cloned this particular repository, so I have just cloned it over here, and just open a command prompt over here and say npm install. So it will install all the dependencies for this particular project. Yeah, so basically I think I have already done that. That way it said audited. So in your case, when you are going to do that, it will say added 55 packages. So that will be the default packages that is necessary for an Express application. Here we'll be using a combination of Node.js and the Express framework alongside something called EJS. So how I created this, let me just open this application in VS Code, which is a handy code editor. So let me just explain the file structure. I think you guys might know this, but again, let me just say that for the flow. So over here, we have a bin. Inside that we have something called www. That's actually a file in which we can specify the details regarding the server, where it will be running, the port, all those things can be specified. Like the port will be specified. Yeah. So whenever we are going to run this server or run this particular application, that will be exposed to this particular port 3000 in the localhost environment. Then inside the public, we will, I only have the style sheets. If you have any public things like images, any JavaScript files or style sheets, then you can provide them over here. Inside the routes will be where we'll be handling the requests from the front end, like what do we need to do with the input that is coming from the front end, or how we need to process them, how we need to give up the output. All those things will be handled inside the routes. The views is where the interface will be created. I'll show you guys the how the interface looks like in a minute. Then Git Ignore. So basically, it's for ignoring certain files. Yeah, 1 second. Right? Yeah, why is the node module not listed over here? Anyway, so inside the app.js is where, like, this is the entry point. I mean, this is actually the entry point, but from there it will be calling the app.js, and inside the app.js will be specifying all the necessary packages that we need to require. Then the router files, like we can specify to which, whenever a call comes, to which program that we need to specify, like for the root call or the root address itself, then you can use the index.router, which will route your calls to index.js routes, where it will be handled accordingly. I'll explain that. Then we have the app, all the normal things regarding an Express framework. I mean, if you want to create a simple framework like this, you can use something called Express generator, I think. Which is an npm module. You just need to install that as a global module, like npm install -g option. And you can use that to generate a symbol. Like, these are the options. You can just simply use it to generate a symbol. A quick way to generate an Express template, actually. If you want to have a starting, then you can use this. Then let me just quickly run this before I explain the routes code and all the things regarding. I mean, I haven't done anything regarding the blockchain in this. It's just a simple application that reads the data regarding the certificate and displays that certificate. There is nothing regarding the connection between the blockchain or anything like that. So let me just run this npm start. So there's actually a configuration file also called package.json. That's actually associated with any node file or node application. So basically, it lists out the dependency for that particular project and any scripts regarding that particular project. So if I just call npm, which is called the node package module, it will go to this package.json and look out for any script called start. So that will in turn call the node and it will invoke this www file. So if there were any error, that will be shown and it will not start. So let's just go to localhost 3000. That is where I want that these things to be exposed. So yeah. So it's a simple website. Basically, if you provide any value, then it will be passed on the server. Currently, it will be passed to the server and it will display it back. It is shown as this because I have a beautify for the JSON values. That's why it is shown as like this. So if you click on the search, the value will be passed to the server. And for now, it will be returning itself back. We'll be changing that to writing it to the blockchain later. Then we have issue certificate, where we can specify the details regarding the certificate, the certificate ID, the name of the candidate, the grade of the candidate, and the issue date also. It's a simple website, and you can, I mean, currently it just goes to the server and bounce back the value. That's how I coded it. And if you want to view a certificate, I also have an interface for that. It simply shows a certificate regarding the details that we store, like the name, the rank, the course, then the date of issue, the certificate number, etc. So I hope you guys understood the simple interface. So basically, in the index or the in the search page, we have a form with an input type text that will take in this the certificate ID, and we have a submit button. And the form is actually a unique or an easy way. I mean, an easy way to send data from the client side to server side. You just need to use a form to collect the data, and you need to specify to which URL you need to redirect that particular action. You can specify it as a post or get method. There are there are several kind of methods, but mainly there are two kind of request methods, like post and get. And post is usually used to send value to the server using the session, and get it is used to retrieve values from the server. Mostly that is why we use this. Then in the issue certificate, I have a form for collecting all these necessary details, and submission it's all the same. View is just a page in which we display these details. So you can see the if you I am using the EJS template engine. There is other template engines also available for Handbrake. It's actually, I think, a Python based. This is actually much more closer to the HTML version. So the template engine, if you have a template engine, then you can insert the JavaScript code inside to that. Like, this is a value that I passed from the server side. So to insert that, I have to use this kind of syntax to do that. So if you inspect the routes, the user.js, I don't use that. It was just there. You can see the first router. This is actually the router that gets triggered when you call the localhost 3000, the route to URL. It will return the index view. It will just render this view. Then as for the view, it's just for I just used it to show you guys the template for the certificate. That's all. And in case of the search, when you enter the search query, this will be the receiving one, and it will receive the value. Then console log it over here. I'm still, yeah, okay. I just checked if I'm still online. So yeah, then we have issue certificate router, post. All these things just receives the value and sends back them right after it receives. So I hope you guys understood the code. Like, you guys can, if you want, you guys can take 5 minutes and go through the code that I have shared with you guys. You can just explore the GitHub repository. Everything is here. Everything I just explained is over here. You guys can maybe go through that. And if you guys have any doubts, you guys can put that in the chat or unmute your mic and ask. The final finished version of this project, or the project that we are going to do, will also, the code for that will be also be provided in the project repository. Actually, it is already there. It's in another branch called complete. So if you switch over to that branch, you will be able to see that. But I prefer you guys to look at that after we after we finish the session. Okay, so yeah. Okay, so if you guys have any doubts, you guys can go ahead and ask.
Sir,
Yeah.
am I audible?
Yes, you are audible. Tell me.
Okay, sir. Myself, I'm Gayatri from Rpc Leaves.
I just have a doubt. Like, I have understood all the code which you have taught.
Okay.
Like, suppose if I need to develop a application, new application, say
Mhm.
for example, a e-voting application or a attendance management application like that. So, how am I to start
Okay, so
coding?
you want to start a like a e-voting application on top of blockchain, right? So
Yeah.
uh, first you need to do is that you need to develop a smart contract, just like we did right now. Next, I prefer if you develop the, I mean, you should prepare an overall picture of what you will be doing. What are the functions for your application? Like for our functions are like, I think my application is still running, right? Yeah, our functions are simply to view the certificate, like to search for any certificate that is already been issued, and to enter or issue a new certificate into the blockchain. So you should have a clear picture of how you can do that. And next, I think you can use if you are not willing to code these things from the scratch. I mean, I didn't code these things from the scratch, so you can use something called Express Generator. I provided that link before, I think. Like for example, you just need to create a new directory. So mkdir, and you can use this thing called Express Generator. And if you have installed the Express Generator globally, you can use this this command to install the Express Generator. Sorry, npm install -g for global. Global means it will be installed in your C directory or in your home directory. It will be available in all projects. That's what I meant by global. So install it as -g. Then yeah, then the name of the package. So Express Generator. So if you have already installed, I have already installed that, so I won't be going to install that. So then use the command called express followed by -e. Then if you open the and check the directory, then you can see that this is actually the same folder structure. I mean, I have added my own codes in there, but this is actually the base code structure from I have started to work actually. So you guys can use this way to start from the scratch. So what you need to do first is to start coding your, start designing your application. I mean, that's actually the base for any project. And after you have designed and decided on your functionality, you need to decide what data that needs the protection or needs the nature of blockchain. So over here for me, I just only need to store the details regarding the blockchain. Like this is actually a prototype. If it is a bigger system, it will have the registration details regarding the colleges, the KBA registration details, the students registration details, the approving mechanism. All those things will be there, but you don't need to store all those data into the blockchain. You just only need to store the required data. Like we can call them smart data or something like that. So you only need to store the necessary data that needs the protection or the nature of blockchain. Then after you decide that, you need to move on how to design the blockchain smart contract. So you guys can do that in a group, or you guys can do it yourself. You need to explore. I mean, first you need to study the entire Solidity. This is not actually the entire Solidity. I just plugged some specific functions for our use cases. Then you need to code in that functionalities. Like for us, you need to store the data regarding the certificate and retrieval. So those are the two things that we needed to do. And after that, you can start with the interface. It is always better. I mean, if you are like developing a prototype, in case of an actual software, that will be divided into, like, the front end will be done by a team, the back end will be done by another team, the smart contract development will be done by another team. But if you guys are like doing a prototype, then it will be always better to have the interface ready first. Then I mean, first develop the contract, then develop the interface, then move on to the communication part between the smart contract and your server side or your interface. Did I answer your question?
Yes, sir. Thank you, sir. And one more doubt I do have.
Yes.
How did you connect the Solidity code with the website, I mean, or the display which you have shown now?
No.
The
I haven't connect.
certificate.
No, I haven't connected the code to the blockchain currently. Currently, what it does is that for example, this is actually the issue code. Whenever I call that issue button over here, let me just show you. Whenever I call this issue button, name Ananthan, some gibberish, yeah. So what happens here is that a connection request is sent to the server, and the server that receives that handles that request, the code that handles that request is this, and that code just receives the data and resends it back. We haven't done anything that stores the data into the blockchain. We haven't done the blockchain part. I just explained, I just showed you guys the part for the interface only. This is the second step I mentioned. You just do the interface step. Then after that, we can do the connection part for the blockchain. That will be coming up next.
Thank you, sir.
Okay. So if you guys understood this code, if even if not, you guys will have time. You guys can go home, and after that, you can also review the complete solution. But let's just go ahead and connect this thing with the blockchain. Or before that, we will be using we used the remix ID to code our program, right? So, but that's not enough when we are doing a project, because you have to compile your contract and deploy your contract using the remix ID, and then copy that address, copy the API, and paste over here. That's actually a tedious manual process. But instead of that, we can use something called a Truffle, which is actually a framework that can be used for the entire development lifecycle of the Solidity code, like compilation, deployment, all those things, testing, all those things. We won't be going into the testing part, but we'll be doing the compilation part. So Truffle is actually a framework developed by someone called Consensus. They are actually a big shot within the Ethereum developer community. They have developed a lots of tools for us. They make our life easier as a developer. So we'll be integrating that Truffle tool to our existing project first. Then we will be moving on how we can communicate with the blockchain network. So to do that, you need to install Truffle globally, just like we installed the what was it, npm generator, sorry, the express generator. Just like that, we need to install Truffle. So basically, I have already installed. I think I have already installed Truffle. I'm still audible, right? This thing seems to be a little stuck. Okay, so -J always requires, if you haven't configured your privileges correctly, you need to provide it with sudo. But anyway, I have installed Truffle already on my computer. So there are two ways in which you can use the Truffle. You can use Truffle init to create your Truffle project from the scratch. So for our example, we'll be using that. So when you specify Truffle init, it will take some time. And it will generate some new files in our directory. Let's just go ahead and check them. So as you can see, contract is a new folder they have created, migration, and they also have a config called Truffle config.json. So we'll be using this Truffle to compile our smart contract and then store that smart contract to the relevant environment. So first, let's just go ahead and create our smart contract over here. So the first thing is that we already have a folder structure, and we want to create our smart contract on this contract folder. And as you can see, we already have a migration.sol. It's actually a contract developed, provided by Truffle to keep track of how many times we stored this particular contract or the contract for this particular project into the blockchain. It's just a counter contract. It keeps track of number of times we have deployed the contract into the blockchain. So if you are using Truffle, we have a command called Truffle create contract, contract, then the name of the contract, certi, then it will automatically create the contract in the like in the correct position or in the correct way. So you can see there is a new file that has been created, certi.sol. It will give you a beginner template. So like you can directly go ahead and create your own smart contract functions on all those things. So we'll be replacing this with the code that we just created. So just copy it from here and paste over here. Now we have our contract. So we can go ahead and compile that. We can do that using the, are you guys able to see this? Okay. So we can do that using a command called Truffle Compile. Oh yeah, so let me just interrupt that because I forgot to do one thing. So remember that configuration file regarding the Truffle? We need to specify which version of Solidity we are going to use, because by default, the Truffle uses Solidity version 0.5. We need to alter that to 8.1 because we are using the 8.1 version over here. So we need to uncomment this line and change the 0.5 to 0.8. Then again, go ahead and compile. So it will fetch the Solidity version for that we specified from the repository and compile our contract. As you can see, after the contract has been compiled, there are one additional folder over here. So this is actually basically where they store the compilation details, like inside this certi, you can see the API contract name, and when we deploy this into the network, then we can get the address corresponding to that particular network. So we just need to import this particular JSON file into our project, and we can do everything automatically. Like we don't need to do copy the API or copy the address each time we redeploy or each time we make a change to a smart contract. We can directly go ahead and Truffle compile, and everything will be available already here. Then the next thing we need, after we compile, the next thing we need to do is deploy the contract into the blockchain. So for that, we actually need a blockchain. We haven't really went into the client part. So let's just quickly go ahead and run a client, an Ethereum client, for us to deploy our smart contract. Okay. Is there any noise coming? I seem to be hearing a noise. Okay, so anyway, let's go ahead and look at the client. So we'll be using the EVM. I mean, every client is actually the implementation of EVM in a particular language. For this particular example, we'll be using something called Go Ethereum. You can go to this particular link to get your client for your particular application. So yeah, it will take some time to fetch. I mean, each time they fetch their latest build from the server, latest stable build from the server. That's why that's a little bit. It takes a little bit time. So for it is available for Ubuntu, I mean Linux, Mac, Windows. So you can go ahead for any versions. But in case if you are downloading for Linux, or if you are installing for Windows, when you are installing for Windows, there will be a stage in which you will be given an option to choose the development tools for this particular application. So there are other tools alongside Git. So whenever you're going to download for Linux, just directly go ahead over here, like it's in the below. Just download the one with the Git and tools. Just don't download the one with the Git, but download the ones with the get and tools, because there will be the extra tools that you guys might need in the future also. So whenever you guys are downloading, just download the ones with the get and tools. So I mean the ones with the most larger files. So download that. Okay, so I already have downloaded for Linux. It's just a simple zip file. You can just decompress it, extract it over here. So I have it on my computer, and I think I have set the file path too. So if I simply say get help. So as you know, get this Go Ethereum is a command line application. We use the command line to run this thing. So the get is the main command, and we can use something called a help. Okay, I think, yeah, I have added that to the system environment files, but I have not restarted the computer. That's why it is not yet. So source is a command used to execute any files within this system. So I just executed my environment variables file. So I think it will work now. Yeah. So this is the get command prompt, and you can see all the necessary commands. These are the main commands, and these are the this is a main command. This is a sub command for different purposes. Like for example, if you simply run get, then that means it will be running it in its default values with its default value. Like it has a lot of parameters. You can specify the values. So if you simply run get, then you will be directly connecting to the main Ethereum network. So do not let it sync with the main Ethereum network. Like if you want to do mining on main Ethereum network, then you have to have a fully synced node into the main Ethereum network. Like you have to download all the data corresponding to a single node. Like that will be around 500 GB. And if you just simply type get, that will be what happening here. If you specify get Robston, then you can connect to a test network provided by the Ethereum developer community called Robston. Sorry, it's called a test net. So if you specify this flag, then it will connect to that one. If you specify Rinkaby, then you will be connected to that particular network also. So that's why you connect to public test networks or public main Ethereum network using get. For our purpose, we will be using a developer version of get actually. I mean, get also provides us with a developer node. So to run that, we can use the command get --http. So we are like asking get to open the HTTP. Like get has 3 ways in which we can communicate with the get. The first one is IPC, inter-process communication. The next one is RPC, remote procedure call, which is RPC over HTTP protocol. So I am telling it to enable RPC protocol, and the keyword for that is called --http. Then I need to specify the port to which it need to expose that. So HTTP port. Usually, most of the developers use 8545 for all the as the default port. So you guys can go with that. Then I need to allow whichever domains that have access to this particular port. So that will be using cross domain. So simply saying cross domains, or whichever domains that has access. I'm going to simply say all the domains will have access. You can specify that using the star. You do not specify it like that. If you only want remix ID to access that, then you can like specify remix.ethereum.org. Then only the remix ID can access this particular node. Like you do not expose your node if you're like actually developing an application. Do not expose your node to all the available sites. Just specify the domain. Like if I am developing it for actual, then I will be exposing it to KBA.aa. Only that domain will be able to access this particular node. So it is always better to filter it out. Then you can specify, I mean, inside get, you have different functionalities, and you can access those functionalities using different APIs. So you can specify which are the APIs that are available through this connection, the RPC connection. I'll be using a DB. These are the default ones that we need if we are connecting another decentralized application to this. Then just like we had flags for connecting to a Robson test network or Ringaway test networks, we have something for dev. It's a developer mode. When you provide this flag, the get will run up in a developer mode. So in the developer mode, you can will be given a proof of authority network. Proof of authority is the consensus mechanism. Like as you know, the proof of work is a consensus mechanism used by Ethereum and Bitcoin. But if you start it in the developer mode, it will just simply run a single node with a proof of authority network. It's a proof of stake variant. Like in proof of stake, you stake your ether or you stake your money. Here you stake your identity. Like in a proof of authority network, I'll be saying like I'm Ananthan from KBA and I'll be validating this block. And in a future future time, any block that I have validated seems to be fraudulent, then I'll be losing my identity and I'll be losing my access to that particular network or my privilege to mine or vet or validate a block. So we can just directly go ahead and run. Before that, we can specify the data directory to store the data relating that particular node. I'll just say data. So it will create a folder called data. I'll just call it dev data so that we know. A folder called dev data in the lab, like in the current folder. So just run it. I think I have something else running on my 8545 port. That's why there is a problem. And the DB is actually a deprecated API. So let's just remove that too. Maybe add admin. I mean, it's not necessary, but yeah. So for instead of 8545, I think I'll go with 7545. Yeah. So like in proof of work, the process of verifying a block is called a mining, and in proof of authority, the process of verifying a block is called sealing a transaction, or yeah, sealing a transaction. Those people who do this are called validators. That's why they are saying sealing paused for now, and they are waiting for any transaction that is going to be happening to the blockchain. So now that we have the client up and running, what we just need to do is that go ahead and deploy our contract. So I'll just close the other terminal that doesn't need. So to deploy the contract using a Truffle, first need to tell the Truffle to which environment it need to connect. So I can specify that in the Truffle config file. So inside the network section, you have something called development. Just uncomment that, and you can specify where it is running, the IP of the machine, the port, Oasis is running in 7545, the network, and yeah, I mean, that's the necessary thing that you need. In network ID is provided as star, so any network ID, like network ID is used to uniquely identify the blockchain network. So I'm specifying any network is okay. For us, I think the network ID will be I haven't specified the network ID, so we'll see. So I haven't specified the network ID. I should specify the network ID also. So let me just stop this application. The chain ID is actually specified over here. It's 1337. So that's okay. So the chain ID or the network ID is 1337. Now let's go ahead and deploy our contract into this particular instance. So to do that, we have a command called Truffle Migrate. Truffle. Sorry about that. Truffle Migrate. Oh yeah, before calling this, we have to write the migration script for this particular contract. So if we remember, when we called Truffle init, the contract and some other folder called migration was popped in. So we have two contracts, right? One here to keep track of how many times we did the deployment, and one here our actual contract. So we need to have migration script for that. And to create a migration script, we have a command called Truffle create migration and the name of the migration file. I just call it certain. Yeah. So if we go back and check, we'll have migration dot. So yeah, this is actually the timestamp, the unique timestamp of the current time whenever I executed this command, followed by the name of the file I specified. So the easiest way to write a migration file for our contract is to copy the contents from the first migration file and then just edit it. So over here, it is requiring the artifact. So when we compile our contract, we had something inside the build folder, right? Build inside contract. These files are called artifacts. So the certi.json is actually the name of our smart contract. And inside the certi.json, we have everything related to the compilation. So this is called an artifact in terms of Truffle. So we need to specify this over here. So certi. Then I'm just changing the variable name so that we don't really get confused with that. Now we have our migration script. So this will specify to where we want to deploy the contract. So the deployer object will read from the Truffle config file, and it will know to which environment we have currently connected. So now we can use the command called Truffle Migrate. So the Truffle Migrate command actually compiles first, then it migrates or deploys to the connected environment. So let's see if everything is okay, then we'll be able to deploy that. Okay, so seems like there are oh yeah, so that was a typo. Okay, so as you can see here, we have deployed our contract into the blockchain. You can see the contract creation that happened, the hash, and all these things can be seen in the log. But the important thing that you need to remember is that if you have the deployed contract address and the contract itself, so let me just get the address. Then we can also load it up in the remix ID also, like already deployed contract can be also loaded. So this is the same contract we have, so we don't, I mean, what are the things that we need to access a contract? The ABI and the address. So inside remix ID, we can't specify the ABI, but we can specify the contract. So you just need to specify the contract, the same contract that we deployed, and we just need to compile it, make the ABI ready. Then use this @address option and call it back. See, it's simple. It's always better to load your contract in the remix ID, so that whenever you want to have a quick way to test your contract manually that is deployed in your node, then it will be helpful for you guys. So now that we have deployed our contract into the blockchain network, our first part has been over. Yeah. Any doubts regarding what we did thus far? Okay, so if you guys have any doubts, you can just unmute your mic or ask, and or put it in the chat. Meanwhile, I'll just go to the next phase. So first we developed our smart contract, then we had our interface configured. Then the next thing we need to do is to connect to this particular or interact to this particular smart contract that is deployed in this Ethereum node. So how we do that? To do that, we need something called Web3. Web3.js is actually a JavaScript module that can be used to communicate between the front blockchain and the server side. like you can interact with the blockchain node using the Web3. Like not only the transaction, you can like control the entire behavior of the blockchain node using the Web3. But for now, we'll be using it to read and write from the particular smart contract. So before we do the read and write operations, we need to configure or we need to specify some things that we need to do. So yeah. So let me just minus that. Now, the first thing we need to do is the first thing we need to do is actually to install the Web3 module. So npm install Web3. So here no -g because we are installing it only for the this particular project. So I think Web3, yeah, npm install Web3. So this will actually take a little bit time. So the one thing I want to mention about Web3 is that Web3 has a little bit of dependencies in regards to CPP. So if you are working on Windows, then you need to have a C compiler. So so in case of Windows, you can use this npm module called Windows build tools. Yeah, so you can use that Windows build tools. In case if you are using a Mac, then Mac by default has something called Xcode that will have a CPP compiler, so you won't have any problem when installing the Web3. And in case of Linux, I don't know about every other distribution, but I am currently using the Ubuntu 20 distribution. So in Ubuntu 20 distribution, you won't be facing any problems. But if you are using like maybe 16 or 18, I haven't like really tried it out with 18, but in 16 or 18, you need to install something called build essentials for Ubuntu. I think it's available as, yeah, you can use the PPA, like you can use the sudo apt to get to install the build essentials. I'll just put this in the chat also. So in case of Mac, you don't need to install anything else. It will have the default compiler. But sometimes in Ubuntu, you will have to install, I think it's for the Ubuntu version 16 and 18. If you install the updates, I think there won't be any problem, but sometimes there will be a problem. So you need to install this thing to have a compiler for the Web3. Then moving on, yeah, so Web3 got installed. If you check the package.json, it will be available there, Web3. Now the next thing is to, we need to create a link to this. We need to specify how to connect to this particular node module and how to create a smart contract instance. Using that, we can call read and write from the smart contract. And we will be specifying these in the app.js because here we can create global variables or define global variables. So if you guys have any doubts, you guys can go ahead and ask. Otherwise, I can like start working on the connection between the blockchain application or normal application with the blockchain. Yeah.
So there is a doubt in the chat. Like, what about for Mint? Like, build essentials for Mint.
Mint, I think build essentials is available for Mint. I have to check it. I haven't checked it for Mint. What is the like underlying distribution of Mint? Mint is a Debian distribution, right? Is Mint a Debian distribution? So Mint is actually based on the Debian distribution, like Ubuntu is also based on the Debian distribution, so there is no problem. You can use the, Ubuntu base. So you can use the build essentials. This the same thing. You can install this on Ubuntu also. There's no problem. I mean, I haven't checked it out. I'm pretty sure you can install this on Ubuntu also. Okay, so yeah, moving on. So the first thing we need to do is we need to require the we need to require the Web3 module. So let's go ahead and do that. Web3, I'm creating a, so if you specify it as var, then that will be, if you specify, 1 second guys. Yeah, so sorry for the delay. So, if you specify it as var, then var or where, if variable or constant, it will only be available. The scope for that particular variable will be only available on this particular file. So I'm not specifying it as a var or variable. So that means it will be available globally. That means it will be available in the routes directory also, where we need this particular instance. So let's just go ahead and require the specify the name of the module web3. It should be the same name as that as specified over here. Yeah, web3. So we got the web3 library. Then the next thing we need is that we need to import this artifact actually. I mean, this artifact actually has the ABI, and if you check in the networks, you can see the address, deployed address of the contract also. So if we import this file, then we can simply load all these things from that particular file. So let me just create a variable called my contract equal to require. So I'll just use path.join function to join the present working directory path with the path to that build directory. So you can use a global variable called the dir name, comma, the path for this working directory. So to get the path, I think you can copy the path from here. Yeah, let's check. Yeah, copy path. Yeah, let's check the relative path. I forgot if it is an absolute path. Yeah, so copy the relative path, not the absolute path, just copy the relative path. Oh yeah, I copied it for the wrong thing. So copy it for this one, the certi.json. Copy the relative path, paste over here. Yeah. So in if you copy if you copy the copy path, it will copy the absolute path. The absolute path means the entire file path. The relative path means with respect to the present working directory. Yeah, so after that, we need to create a variable using this web3. I mean, we have currently imported the web3 modules. Now we need to establish connection with the blockchain node, the node that is running over here. So to do that, we can use this syntax called, I'm creating another variable. Let's just call it constant. Let's create a constant variable because we don't really want to change. So do check that this is actually a small case. Here we use the capital case. I am just using it because it will be the same. In the end, we will be using this one. So moving on, we'll be creating a connection using the web3 module that we just imported. So yeah. Yeah, actually you don't need this line. You can just forget about that. Then web3, then inside that you need to specify to which node you are connecting. So you need to specify the RPC location, port location, or RPC connection string. So the RPC connection string, I mean, we can get that by, if you remember the connection string from the command that you have provided. Where is the command? Yeah, as you can see, we haven't provided the IP address specifically, so that means it will be running on localhost and the port will be 7545. You can see the RPC endpoint somewhere here. Yeah, this is the RPC endpoint. So you can specify the RPC endpoint over here. Need to specify it in the full. It's an HTTP. Look, it's not a secure protocol, so it's only HTTP. Not there is no S alongside that. So HTTP : local host, and I think it's running on 7545. So this is the string for establishing connection. So after I have established the connection, I'm creating another variable, account address. So whenever we do a transaction, we need to have some guy pay for our transaction, right? So in case of our node, we have a by default an Ethereum address. I think we'll have an Ethereum address. To get the address, you can either copy it from over here, or if you didn't find it out in the logs, or you did a lot of transaction before that, then you can connect our application or our remix ID using the Web3 provider option. So instead of the JavaScript VM, use the Web3 provider. So specify the connection string. It will already have something over here, and you can get the address. And this is actually the Ether balance. I mean, this is actually a developer network that we created. So we'll have a big amount of pre-funded Ether. So get that address. So this is actually also specified as a global variable. So it will be available in the routes directory also. Then we need to specify the contract address. Contract address, which we can retrieve from the my contract. Actually, just call it my contract JSON so that we can know that it's a JSON file object. My contract JSON. Then I mean, it won't be shown over here, but I am actually calling the sections, each section. So the major section is network. So my contract.json. Sorry, yeah, my contract.json.networks. Inside that we have the network ID. Then you need to specify the section name, and that can be provided like here 1337. Then dot the subsection inside that. That will be, I think, address. So it's address. Now we have the smart contract address loaded into this contract. Next, we need the, I mean, I have just declared it as a global variable. You can provide it as a local also, because we won't be using it in a further contract. Then we need contract KBA. So that can also be gotten the same way, my contract.json.ap. So it's actually the subsection. So you can directly get that. I think it's one of the main subsection. As you can see, that it's a main subsection, so you don't really need to go into the sub variables. So now that we have the address and API, we need to create an object using these two things, so that we can use that object to access the smart contract. To do that, I'll just call it my contract equal to using the new keyword, and using this Web3. This instance that has been already been connected. In this instance will have the connection. So using that instance Web3, then you need to specify web3.eth. Contract. Then inside that you need to specify the contract ABA and a contract address. Now we have an instance using which we can actually access this particular contract. So this is actually the initial configuration for doing this. Now we can just simply use this my contract to read and write data from the blockchain. Okay, so do you guys have any doubts to the things that we have just done? Like if you are doubtful, like if you think that you have made a mistake, you can just do an npm start, and if it starts successfully, yeah. So in the latest version, I'm using the latest version of Web3 1.3.5. The SSH is actually the Whisper protocol, and the BSS is, I think, SOM protocol, and those will be deprecated from the Web3 package because no one is using that. Like Whisper protocol is used for communication between peer-to-peer, and SOM protocol is actually used for the same purpose. But no one is actually using them via Web3. That's why they are removing from the Web3 package. So if no other error that has been listed, then that means our code up to this far is working perfectly. Now let's just go ahead and write and read data from the blockchain. So first thing is we need to write data into the blockchain. So that is what we do in the issue. So in the issue place, we are actually calling, and where is it? Yeah, so there's a form. Yeah. So action is issue. So let's just click in the routes. The user is not a user. So this is the post route. So this is the one that is being invoked when we create a new certificate. So here we already have collected the data from the front end. I'm just console logging it. I'm no longer going to send it back. I'm now going to send it to the blockchain. So let's see how I can do that. So to send a data to the blockchain, what we need to do is that we need to use the object that we just created. And inside that object, we have some methods to do that. Okay, so first one is issue, right? So first, the contract object that we created called my contract. Then inside the my contract, we have something called methods. Then inside the methods, so basically inside the methods, all the publicly available functions, like the inside our contract, we have two functions, right? The one in the same variable name as the certificate details, and the another one is new certificate. So we can call the new certificate from there. New certificate dot, sorry, not dot, you need to open the parentheses, and you need to input the parameters. So here we have certificate ID, course name, candidate name, grade, date. So let's just go ahead and this is where I got all the data from the request. So I can call them one by one, like calling them dot. I think it's first one is certificate ID. Let me just close this and also enable word wrap. So the first one is certificate ID, I remember. Then the next one is course name, candidate name, etc. So yeah, data dot course name, then data dot I think it's candidate name. Yeah, if it is wrong, we can like check that then. So data dot, I think grade maybe. Then data dot date. So we passed. Then we use a function called send. Whenever we are writing data into the blockchain, we use the function send. Open the parentheses. Inside that, we need to specify something. So the first thing is we need to specify from which account we will be paying the gas cost for that. We already have an account. So I think that's the same variable name, right? Anyway, keep in mind that you have the same variable name. Then I'll be using a promise function over here. Like all the calls that we are going to call into the blockchain node is actually threaded calls. Like you call them and you have to wait for them. Like you can use the callback function. I don't really like the callback function. I'll be using a promise function, or you can use the async await functions also. Like these are the ways in we handle asynchronous calls in Node.js. You can use a callback, promise, or any async await functions also. So any method is possible. So I am writing in a way the promise way. I mean the promise method. So dot then, and inside that I'll be using an arrow function, and the arrow function here I'll be specifying the txn. So the txn will be you will get the data regarding the transaction inside the txn. We won't be like using that anywhere, but after we got the txn, we will open the function and we will render out. I mean, I already have commented the render over here. So we will render our page issue certificate. I mean, I'm just re-rendering it with the form hidden. That's the only thing I'm doing here. It's just a form hidden call from here. So that's how we do that. So yeah, that's the entire thing we need to do in order to write the thing. So if you want to know the details regarding that particular transaction, then we can also do one other thing, but let me just show you how this works. npm start. Okay, localhost 3000 issue certificate. So it's on blockchain developer certificate ID, specify certificate ID, name, and grade, issue date, and issue certificate. So basically it's issued, and yeah. So a transaction has been submitted, that's okay. Now I need to go back, and now I need to retrieve. So in case if you guys want to see the transaction details, then I can out the transaction details. I mean, all the transaction details will be in this object, so you can just need to send it back. So res.send and the transaction object. So txn, I think. So now this time when we create a new certificate, yeah. Oh yeah, sorry, I forgot to, like, whenever we change anything in the app.js and route, you need to run it again. I haven't passed any value for the certificate ID. That's why I haven't shown that over there. So like, I can pass the value for that certificate ID also. Anyway, let's just go ahead and run it again. So any changes that we do to the route files or the app.js file, we have to rerun our server. Otherwise, you can use something called the node mon. So that's actually monitors for the changes in the file and reruns the server for ourselves. So issue another certificate. So like you can see this is the block hash, block number, contract address, all those things can be shown here. So the contract address will be null, but the to address will be shown here. That's actually an error. That's can remove that. Then from gas used, logs, all those things will be shown. Okay, so but for us, we'll revert back to using this one because that's actually a message. But the other thing is actually only understandable the researchers or the developers. So yeah, let's stick to this one. Now, now that we have written the certificate into the blockchain, now we need to retrieve that, right? So to retrieve, we'll have to go for the index.js file. Here we have written the code for like inputting the certificate number and submitting it, and it calls the issue. No, it need to call the view actually. That was actually an yeah, typo error. You guys need to, I mean, in the final solution that's okay, but in the template it's calling the view. You need to change calling the issue. You need to change that to view. Otherwise, it won't be working. Okay, so let's go back and look at the index.js router and for the view for the post method. So here it is the post method. So for the view post method, we got the data. Like we got the data. Now using that data, we need to retrieve the data and show it. So yeah, let's go ahead and do that. So it's the same as doing the same thing before, like using the method, the object to recall it. Okay, so let's go ahead and do that. Okay, so we have the data. So let's use the my contract dot again methods dot the method name. So here we have the method name as certificate details because as I told you before, any state variable that is set as public will have its own getter variable. So like We can see that over in the remix ID also. See, certificate details. Now let's call the certificate details. Yep. Certificate details, and then you need to pass the value. So that is data.certificate. So candidate name, so certificate ID, I think. Yeah, certificate ID will be the value. Then .call. For reading data, we will be using the method called .call. You can either specify the address or not specify the address. From this point of, for this reading, you don't really need to specify the address, but you can specify it like this. Then .then and another arrow function result. Let's just call this a result. Then inside that, I need to I can like console.log it for our purpose of what we are getting from that. But I'll be rendering that view.js, view.ejs file I have created. So I have specified the data. I'll be receiving a variable called data with the members candidate.name. So that will be the exact result that I'll be getting. So let's just go ahead and do that. So yeah. Okay, so let's just give it some value. I think I call it data, and we'll pass the valued result. So yeah, view certificate result. So that's actually does it for us. And let's see. Go ahead and check the value. Yeah, seems like there are no errors. So localhost. Let's provide the certificate name. Yeah, so seems like we have a slight error. So yeah, we have the course name, candidate name. So in the views, I think there are some problem with the view. So candidate name. So what's the problem? It's not displaying the candidate name. I don't know. Let me just check it out. It's showing the. It's not also not showing the certificate ID also. Okay, maybe I. Yeah, okay, so certificate ID. And let me just, yeah, I haven't passed the certificate ID, that's why the problem. Yeah, so there was a typo with the candidate name, and for the certificate name, I haven't passed that. So let me just pass that alongside this. So ID can be directly passed from here, right? So, I mean, that's not a good practice, but I'm just doing it for right now. Okay, close it, run it again. Okay, so let's retrieve that. Let me just check if it is actually working. Yeah, okay. in terms of that, it is working. Yeah. Oh yeah, so not only I have changed the value over here, I need to change it over the Vue.js over here also. So that's a certificate. Yeah, let's call this certificate. Yeah, so that's the entire project that I want to show you guys. So if you guys want to deploy this to a test network, then you can run this node connected to a test network, but you have to wait for the entire test network to be synced. You have different modes like fast and light, but those are like prototype modes, but you can use those prototype modes to write data or read data, but you won't be able to use it to mine. In any case, you can only mine in Ropster network. You can mine in Rigaby network because that's using a proof of authority. Rigaby, Goril, Coven, all these test networks provided by the Ethereum developer community are using the proof of authority. And in those, there is no mining. In Ropster, there is mining. That's why it is actually called the true test network of Ethereum. So yeah, that's how we develop an application using Ethereum. It's actually a simple application. This is actually and I think yeah, it's actually a certificate. It's actually a stripped down version of the thing that we developed for us. We have a certification portal, but I entirely forgot about the So the one I showed you guys is actually the stripped down version of this portal. I don't remember any. Yeah, I don't remember any credentials actually. So yeah, I don't remember any good credentials. So guys if you guys come to us and do our certification course, then you will be able to get that. So yeah, that's the entire application.